Hello, everybody. This is Miss Eisencraft with Unit 6, Lesson 8 practice problems. This is on page 73. And it's numbers 1 through 4 only. Let me make sure that that is correct before we move on. So sorry. Yes, that's correct. All right. So first one, we are going to draw a diagram to show that 2x plus 5 times x plus 3 is equivalent to this right here. Okay, so when we're multiplying, it's nice to show like, this is called like an area model or a box model to help you remember that there's 4 multiplication problems happening here. So I'm going to take this term and put it up top, put 2x plus 5. I'm going to put x plus 3 here. And it doesn't matter how you draw it. Okay. Now, what we're doing is, as we're multiplying, is we're thinking of these as the dimensions of the sides here, and we're going to multiply them. So 2x times 1x is really just 2x to the second power. Over here, 5 times x is 5x. 2x times 3, if you have 3 groups of 2x, 6x. And 3 times 5 is 15. So these are all of the products. So let's put them into one expression. We have 2x squared plus 5x plus 6x plus 15. And as we learned in middle school, these are like terms, right? These can go together. So we have 2x squared plus 11x plus 15. There we go. So this and that are equivalent. This is unmultiplied out. This is multiplied out. We call this factored. All right. Next, we're going to match each quadratic expression that is written as a product. Okay, so written as 2 things multiplied by each other. Which one goes with which? So let's start with this guy. Okay, x plus 2 times x plus 6. I'm going to use that box method. It's just a really good way to make sure you don't forget anything. Since they're all positive, the only time I really put a sign with the second number is if it says minus. Okay, now remember, I'm multiplying these because think of it like area. I'm multiplying to get the product here. An x times an x is an x to the second power. A 2 times an x is a 2x. A 6 times an x is 6x. And a 6 times 2 is 12. So that turns to x squared plus 2x plus 6x plus 12. These go together. X squared plus, that would be an 8x. Those go together. Plus 12. Okay, so I believe A matches with number 4. Okay, let's try B. That was A. Okay, so B, I'm going to take those 2 pieces, 2x plus 8. And it doesn't matter if you write it along which side. It does not matter. X and 2. Okay. A 2x times a 1x is a 2x to the second power because we have an x times an x. An 8 times an x is just an 8x. A 2x times a 2 is a 4x. And an 8 times a 2 is a 16. So we get 2x squared plus 8x plus 4x plus 16. These bad boys go together. All right. So that one, B, do I see that? Yeah, I see it's number 3. My fancy arrows. Okay. Oh, new sticky note. C. And some students get way better at these and can start doing them mentally, and that is okay if that is you. X 8x plus 4. An x times an x makes an x squared. Okay, multiplying. 8 times an x, 8x. 4 times an x, 4x. 4 times an 8, 32. X squared plus 8x plus 4x plus 32. These go together. Okay. Ooh. Letter C is 1. Last one. Now we know it probably should be number 2, but still it's the whole point is to practice the math, right? So let's practice it. So I have a 2x and a 6 and an x and a 2. And it wouldn't matter if you put them, again, on either side. So a 2x times an x, this square will give you 2x to the second power. A 6 times an x, 6x. A 2x times a 2, think of 2 groups of 2x, 4x. And 2 times 6 is 12. 2x squared plus 6x plus 4x plus 12. 2x squared plus 10x plus 12. And yay, it works out. All right, let's keep on checking. Number 3. Okay. Select all the expressions. So it's like going backwards. It's like after it was multiplied out, that gives us x squared plus 4x. So some of these, right, you could use the box method, but I'm thinking from middle school, like the distributive property, just this x needs to be multiplied here and here. You could also set it up like this, right? Call this just x and this x plus 4. And you would get x squared plus 4x. That's another way to model it. So when you multiply those out, yes, that does equal this one here. Okay. X plus 2 to the second power. What in the heck does that mean? Well, that means this. This literally means x plus 2 times x plus 2, right? And again, that's going to be a lot of multiplying. If you try to distribute, you oftentimes will forget how many you have. Like you could go like this, right? And multiply all those out, or we could use the box. X plus 2 times x plus 2. You're going to get x to the second power, 2x. It's very easy to get these confused, x squared and 2x, and they mean something completely different. X times 2 is 2x, and 2 times 2 is 4, which leaves us with x squared plus 2x plus 2x plus 4. These make 4x. Okay, that does not equal that because there's this extra 4 there. Okay, so nope. How about this one? Let's try it. I have a little bit of room here. Let's try C. X plus x, and then x plus 4. This is the letter C. Let's see if this equals, we're seeing if it matches this. X squared, 4x, another x squared, and another 4x. So we have x squared plus 4x plus x squared plus 4x. This is a little different than what we've seen before. These are like terms. So when we add them, think of them as objects. I have 1x squared plus another 1x squared. That's 2x squareds. And then I have a 4x plus a 4x, which is an 8x. Okay, that is not the same. Nope. No siree. Okay, this one looks like fun. What? Okay, we already did the x plus 2 squared. I'm going to, right here, right? So for letter D, we've already done this portion, x plus 2 squared. And it's just asking us, see how the minus 4 is out here all by itself? Means complete this and then subtract a 4 off the end. So if this is x plus 2 squared, right? This was the result of x plus 2 squared. And then it says we'll take the 4 away. Okay, so this is the same thing as x plus 2 squared, right? And this is now take 4 away. It would get rid of this little piece here that was extra and then make it match. Right? So I had already done that work for x plus 2 squared. And then if I just take away that last 4, it is equivalent. Hey, yo. Last one. If you notice, they just put the x over here. Okay? And it's just like switching these around, right? And multiplication is commutative. And you can even go like this. X times the x is x squared. And x times 4 is 4x. That also is the same. Okay, last one. Here we go. So it was A, D, and E. Lots of fun math there. Okay, Tyler drew a diagram to expand, to multiply out, to expand x plus 5 times 2x plus 3. Okay, so far so good. He put this here. Good job, Tyler. This here. Okay, so he multiplied 2x times x and made it 2x squared. A 3 times an x, 3x. Ruh-roh. Right here is his mistake. Tyler. Right? He should have, let me try this times this, right? That is supposed to be multiplication, right? You're multiplying these. It's very easy because once you get your answer, you're, writing this as an expression and you're adding all these. Some of them can go together. But to get this number in here, you're multiplying these two dimensions. Okay? So the 2x times the 5 should be a 10x. So 2x times 5 equals 10x. Tyler accidentally added the 5 plus the 2. Okay, and those even can't add together because in order to add them, you would need an x with it, right? This would have to be a 5x even to make that work. So this here should be, also, Tyler, what up? He also, look here. That's supposed to be 5 times 3. And then, so he also added 5 plus 3. So remember, this is the act of multiplying. Think of area. And then when you write the expression, then you're putting all of these in one expression or adding them or combining them. Instead, of 5 times 3. Okay. So really, this should be a 10x, right? And then this should be a 15. He was good to go here. So now, what is the correct expanded form? It should be 2x squared plus 3x plus 10x, right? Plus 15, and then these guys go together. All right, that is the correct expanded form. I love those. Those are so much fun. All right, happy mathing.